Okay, this is Algebra 2, Section 6.5. We're going to talk about properties of logarithms. Don't forget that we're skipping 6.4. So these properties, remember when we were talking about properties of exponents, you're going to see some similarities between these properties. Like, for instance, on the product property, we're adding. Okay, when you're multiplying same base, but you're multiplying two things together, it's the same as the log of that base of m plus log of that base of n. You're going to want to write these down and probably, memorize them. The quotient property, log base b of m over n is equal to log base b of m minus log base b of the denominator, n. The power property is a little different. Log base b of m to the n is, you take that exponent and bring it out. It's now a multiplier of this part. So it becomes n times log base b of m. So let's just demonstrate some examples that use these properties. So in this example, we have log base 2 of 3 divided by 7. Well, remember, from just what we talked about the previous page, that is equal to log base 2 of 3, the numerator, minus log base 2 of 7, the denominator. And we just do that on the calculator, and we get approximately negative 1.222. So one thing you guys are really lucky about, I forgot to show you this. So on the TI-84s, those are the gold ones that we have in class, the graphing calculators, you can use the math button to enter logarithms with any base. And you just hit the math key and scroll down until you see this, which is really, really handy, because some of these you don't even really need the property, right? But if you don't have one of those calculators, you're not going to be able to do it that easily. So unless you have one of those calculators, the only way you can do these problems is if you're given these amounts, like in a table or something. And actually in the book, which is where these examples come from, the textbook, log base 2 of 3, they told you is 1.585, and log base 2 of 7 is 2.807. So that's the only reason I have these numbers here, is because those were given. But if you have a TI-84, you can go to the math, choose this, and then you can just enter this. So you would do log base 2 in parentheses, and then put 3 divided by 7 and enter, and it would give you this answer. I was actually pretty excited when I saw that, this right here, because it's going to make your life a lot easier. Okay, so this example, log base 2 of 21, because I was given, pretend I don't have a TI-84, and I was given the value for the log base 2 of 3 is that, log base 2 of 7 is this. So then this is really the same as log base 2 of 3 times 7. Well, I already know what that is, and I already know what that is, because we add those. If we're multiplying, 3 times 7 is 21. I can rewrite it as 3 times 7, and that would be approximately 4.392. So log base 2 of 49 is log base 2 of 7 squared. Well, I already know that the log base 2 of 7 is 2.807. And so, and then remember the rule here, the power rule, is that you take this exponent and it becomes a multiplier in front. So you would take the 2.807 or 808 and multiply it by 2, which is this. The next section we're going to talk about, well, the next, not section, we're in the same section. We're going to talk about rewriting logarithmic functions. So either rewriting, we're going to be expanding or condensing. In this case, the directions say to expand the natural log of 5x to the 7th divided by y. Okay, so I know from my properties that we just discussed that when you're dividing, this is the same thing as the natural log of this numerator minus the natural log of the denominator because of the quotient property. Okay, so then this I know okay. Sorry about that. So this is a product 5 times x to the 7th, which I know can be written as the natural log of 5 plus the natural log of x to the 7th minus the natural log of y. I'm going to use the power rule for this part, and that becomes 7 times, that looks like 71, I'll put this in there, 7 times the natural log of x. These stay the same. And that is this problem here expanded. So now here's an example where it gives you an expanded logarithm and wants you to condense it. All right, so let's look at this part first. I know this really is log, the common log of 2 raised to the 3rd power. Excuse me, so I'm going to go ahead and write that there. And I also know that when you're adding these two, it's really the log of this times this. So I'm going to write that there. And when I'm subtracting, I know it's really the log of this divided by this. So now I'm going to put that there. And now I'm going to go ahead. I could have done this at any time, I guess. 2 to the 3rd power is 8. 8 times 9 is not 78. Yeah, that should be the natural log of 72 divided by 3. And if I do 72 divided by 3, I get the log of 24. So this big long thing right here condenses to that. Pretty amazing, huh? Okay, so this is going to be a really important thing to know how to do if you do not have a TI-84. So if you have anything before the ones we use in class, you're going to have to know the change of base formula. So you have the log base C of A. It's the log base B of A over the log base B of C. In other words, you could change it to common logs where the base is 10, or you could do natural log. So let's say you had, let's just do some problems. So if you don't have a calculator that can do any base log for you, you need to know how to do the change of base formula. So let's say we have log base 3 of 8. We're going to take, remember, if it doesn't have anything down here, this is a common log with the base is 10. So log base 3, we're going to change it to the common log of 8 divided by the common log of this base. And any calculator can do common logs. And that's why you do the change of base, so that you can figure out these weird logs with the base other than 10 or E. Remember, base E would be a natural log. So log base 6 of 24 is really the natural log of 24 divided by the natural log of 6. And I can do that on the calculator. So let's look at this word problem. Seems kind of long and looks really complicated, doesn't it? It's not that complicated. Okay, so for a sound with intensity I, measured in watts per square meter, the loudness L of I of the sound in decibels is given by this formula. This I sub O, that's how you say that, because this is a subscript. This is usually always the initial. So I sub O is the intensity of a barely audible sound. So that's like the initial point at where you could hear something. And that amount is about 10 to the negative 12 watts per square meter. Do you need to know that? No, not really. So you turn up the volume of a song so that the intensity of the sound doubles. And by how many decibels does the loudness increase? So I is the original intensity. So the increase in loudness is going to be 2I minus whatever the initial, or whatever the intensity is to begin with. So you just set up your formula, except now I want it to be doubled. Instead of this, I want it to be doubled. And I'm going to subtract the function of where I started from, which is the original problem. So this is doubled, and this is where it originally was. So notice that both of these terms, this is a term and this is a term, they both have a 10 there. So we're going to go ahead and divide that out, the 10 out, and then you're going to write down what's left over. And I rewrote it here so we don't get lost. Notice I'm subtracting, so that's really the quotient property. So that means what I'm dealing here with is 10 log of this divided by this, not that. Let's simplify this mess. My gosh, look at that. So that's really 2I over I sub 0 divided by I sub 0. But remember, when you divide fractions, you keep the first fraction the same, and then you multiply by the reciprocal of this. The reciprocal of this is I sub O, 0, over I. Well, that cancels that, and that cancels that, right? So basically what I'm left with then is 10 times the log of 2. Well, I can do this on the calculator. The common log of 2 and then multiply it by 10 gives me the answer of 3 decibels. So this really super complicated looking mess right here. Simple algebra simplifies it up fairly quickly. And that's it for 6.5.